Hello everyone, welcome to my YouTube channel. My name is Vaishali Raikar. Today I will be explaining concept regarding how to implement sliding window protocol with positive acknowledgement with retransmission protocol. My USN is 2SB22EC114. I am from STM College of Engineering and Technology, Dhar. Before practically implementing the concept, let's understand the theory behind it. The sliding window protocol with positive acknowledgement and retransmission is a reliable data transmission protocol. It sends multiple frames before needing acknowledgements, waits for positive acknowledgements from the receiver, retransmits lost or corrupted frames based on the timings. First, coming to sliding window, a logical window that controls how many frames can be sent before receiving acknowledgements. The size of the window determines how many frames in flight the window slides forward as acknowledgements are received, allowing new frames to be sent. Positive acknowledgement. The receiver sends an acknowledgement for each correctly received frame. If an acknowledgement is not received within the timeout, the sender assumes that the frame was lost and retransmits. If a frame is lost or damaged or the acknowledgement is not received in time, the sender retransmits the frame. This ensures reliable delivery of data even in the presence of errors or packet loss. Coming to the sender side, it maintains a window of sequence numbers for the frames it can send. Sends all the frames within the current window. Then it starts timer for sent frames. It waits for the acknowledgement. On receiving the acknowledgement, slides the window forward. Means it gives further sends new frames as space becomes it is available for new frames. On timeout, if the acknowledgement is not received in time, then it retransmits the frame depending on the ARQ method. Next, coming to receiver side. Coming to receiver side, it receives the frames from the sender, verifies the integrity, means it checks whether the received frame is correct or not. Then it sends the acknowledgement, accepts and processes the frame. If the frame received is incorrect or out of order, then it discards the frame. In the same way, it may send or wait for the retransmission. Now, let's implement using C code. This is the C program that simulates the sliding window protocol with positive acknowledgement and retransmission, which is also known as go back N ARQ, which is a key concept in computer networks. First, here we have used standard libraries to point or to print output, generate random numbers, get the system time for randomness, and also use sleep to stimulate the network delay. Next, total frames we have used as 10. It is the number of data packets we want to send. Window size. Defines how many we can send before waiting for the acknowledgements. We have used it as 4. Next, Biot send frame. This is the function just prints which frame is being sent. There is no real transmission here. Next is the receiver acknowledgement program. We simulate the real world network behavior. Sometimes acknowledgement won't make it back. Random that is used uh, that randomly decides if acknowledgement is received or lost. Next, coming to the main function or the piece. First, we simulate the task. Piece marks the oldest unacknowledged frame. Next frame tracks the next frame to be sent. Next, send frames in current window. We send all the frames that fit in the current window, stopping either when the window is full or when we have sent all the frames. We go to each sent frame and wait for acknowledgement. If all acknowledgements come back, great, the window slides forward. If even one acknowledgement is lost, we go back and resend from that frame. That is why it is known as go back in action. Next, here we get the sliding window. If all the frames are sent and all the acknowledgements are received, a message is printed saying that all frames are sent and acknowledged successfully. Now let's run this code. Now let's look at the actual output of this program. In the first step, the sender sends 4 frames because the window size is 4. Here, frame 0 is received, but frame 1 is lost. Hence, it is retransmitted. Hence, in the second step, from frame 1, all the 4 frames are sent. Hence, here, frame 1 and frame 2 is received. Again, frame 3 is lost. Hence, it is retransmitted. Hence, that means the sender doesn't know if the receiver got it. So, as per the go back n rule, we go back and retransmit the lost frame. When the frame is received, acknowledgement is received, great, right? If, but frame 3 is lost at this time. So again, we go back and retransmit from frame 3 onwards. Hence, same way, all frames are sent and acknowledgement are received. When all the frames are sent and acknowledgement is received, we get the output as all frames are sent and acknowledged successfully. Thank you for watching.